linear equations. The first example is on the board. I know most of y'all already know, or you should know, slope-intercept form, which we will discuss later in this section. But in the first example, I want you to go ahead and get used to making tables of values. For lines, we're going to use different methods. We're going to use slope-intercept form, we're going to use standard form, but we also want to be able to use tables. And that's what I'm doing in the first example. How many points does it take to make a line?
2.
2. All you need is 2. So in your table, here's the first example. Graph y equals 2/3 x plus 3 on a coordinate plane. So in your table, you can choose whatever value you want for x and then solve for y. So the easiest values I saw for x were 0 and 3. And we added a third point. You don't need this third point because we just said it only takes 2 points to make a line. Why did I choose 0 and 3? Why did I choose 3?
Because the denominator is 3, so
Yeah.
it'll divide out.
They'll divide out. So again, you can choose anything you want. If you want to choose 1 and 2, that's fine, but you'll end up getting a fraction as a result. And it's easier to graph whole numbers. So if I choose 0 for x, what's 2/3 times 0?
0.
0 plus 3
3.
is 3. What about 2/3 of 3?
2.
2 plus 3? 5. So once you get those 2 points, just plot them. 0, 3 is here. 3, 5 is here. Connect them with a line. Then I went on to choose a third point, which you don't have to do, just to show that it was going to lie on the line also. I plug in -3, I should get -2 plus 3, which is 1, which is right here. Okay?
So are we doing a solving for x?
No, you're choosing a value for x and solving for y.
So it doesn't matter what value?
And it does not matter what value you choose for x. But like I said, these 3 were easy values to use. 1 and 2 wouldn't be as easy, just because if you plugged in 1 for x, you would get 2/3 times 1, which is 2/3. You'd be left with a fraction. But that's up to you. All right? Write this down.
Sure.
Definitions. Y-intercept and x-intercept. Y-intercept is basically where you cross the y-axis on a graph. The point the line intersects the y-axis. And the x-intercept is the point the line intersects the x-axis. And we're going to use x and y intercepts when we're graphing in standard form, which is listed below. Any questions about the x and y intercept? Everybody understands that? Standard form of a linear equation: capital AX plus capital BY equals capital C. AX plus BY equals C. And 2 things that we need to remember when we get things in standard form is you can't have fractions, and A must be positive. Has everybody seen standard form? Well, you should have. I mean, we did that in Algebra 1 a lot. So the different forms we're looking at right now are standard and slope-intercept. All right, standard right now. I think this is easy to graph in. Some of y'all probably like slope-intercept form better. Does everybody have all that?
Or
All right. Graph 3x plus 2y equals 120, and you'll see why I think it's pretty simple to graph in standard form. What is your x-coordinate of the y-intercept? When you're crossing the y-axis, what is your x value? Somebody said it, I think. Whenever you're crossing the y-axis, which is this one, what is the x value?
0.
0. So to find the y-intercept, what do you set x equal to?
0.
0. That's all you have to do. So if I set x equal to 0, you're just left with 0 right here. And what are you left with? 2y equals 120. So what does y come out to be? 60. So that is why my y-intercept is 0, 60. Okay? Same thing for the x-intercept. When the x-intercept, when you're crossing the x-axis, the y value is 0, so you set y equal to 0 and solve for x. You're left with 3x equals 120, so what does x have to be? 40. So that's where I get the x-intercept to be. Now you don't want to plot these big numbers, so you can change your scale and just mark it up here that I changed my scale by tens. But you don't have to change them both, but in this case I would change them both to go by tens. Yeah.
Can you explain how you got
40?
40?
You plugged in 0 for y. What's 2 times 0? 0. So you're left with 3x equals 120.
So
Then
it's just
divide
like a
by 3.
reverse cycle. You switch it.
Yeah.
After.
So basically, to get the x-intercept, you can just ignore this term and solve for x. To get the y-intercept, you just ignore this and solve for y. That's why standard form, I think, is pretty easy. Okay. Question on that? All right, write down that definition. All right, slope is rise over run. Which way are you going for rise? Up or down? And run? Left and right. If you rise up, is that positive or negative?
Positive.
Positive. Rise down is
Negative.
negative. Run right,
Positive.
positive. Run left, negative. All right, so this formula is how you would calculate slope. Difference of the y's divided by difference of the x's. And from restrictions, when we did restrictions a couple of days ago, you know that x2 minus x1 cannot equal 0. Okay? If x2 minus x1 equals 0, well, you get an undefined slope. All right? Example, find the slope of a line passing through the points 3, 2, and negative 9, 6. You could do it one of two ways. You could plot the points and just count how many you're rising vertically and how many you're running horizontally. Or you can use your formula. It's probably faster to use the formula. So I would find the difference of the y's, 6 minus 2, divided by negative 9 minus 3. You end up with 4 over negative 12. You have a slope of negative 1/3. Okay? If you have a negative slope, your line will always go in this direction. See that? Positive slope would go in that direction. All right, any questions about negative 1/3?